Okay. Hi, my name is Eugene Chou. I'm a teacher at Dublin High School. I teach in the mathematics department, but I also teach one section of principles of engineering. My background is in mathematical sciences and industrial engineering. I studied mathematical sciences at UC Santa Barbara and then went to Calvert for my degree in industrial engineering and operations research. Sort of made my way into teaching through some community programs and kind of stuck there ever since.
Hi, my name is Calvert, and I've been a teacher here at Dublin High School for the past 8 years. My training originally as an electrical engineer. I got my bachelor's degree from San Jose State University in 1985 and spent the next 16 years working in the high-tech industry down in Silicon Valley. Did mostly work in telephony, and about 9 years ago decided that I wanted to make a career change, and so came to my local high school. Both of my children graduated from this high school, and have been working in the math department teaching algebra, algebra 2, and geometry, as well as computer programming. And I teach the other unit of principles of engineering. All right, this is a program called West Point Bridge Designer. And this was designed and developed actually by an engineering instructor at West Point in New York. And it is a simplified version that allows the students to essentially make changes to a bridge, either one that's pre-made or one that they come up with themselves. And they can build any kind of structure here, and then actually gives them the ability to run a simulation to see if the bridge will actually withstand the requirements of this truck going over the top of the bridge. And as you see in this case, it does. But it's pretty simple to fix as well, or not fix if you will. So we'll go back, and what we can do is we can go ahead and edit some things. Perhaps we can just take out a couple of struts and then go back and run it again and see, it's now unstable. It will no longer even run. So we have to go back and reinsert those items. There we go, there and there. So I'll actually change them a little bit and see, okay, does that actually work now? And it does.
Well, the bridges will show the students how much tension and compression is on each of the members so that they can adjust the beams to different types of materials or change them from a solid to a hollow tube. So in addition to the load test that they're doing here, they can also pull up a report, and it will go through each of the different members and tell them, information about the member size, the section, the material, in addition to telling them, how much forces of compression or tension are placed on each of the beams. And again, this could be used, if they see one of the members failing, like on some of the bridges when they drive over, let's say it fails, they might see one of these turn a really dark red or really dark blue and then break. And then they would know that member, these members in this region would need to be changed to like a stronger material, or they need to change the truss design at that location. So this is sort of a sample of one of the projects that the students would be working on, constructed from the fischertech kits. So the fischertech, they make sort of these mini models of manufacturing systems. So this is just one example of how they could create a conveyor belt system, and they would automate it using these switches and wires so that power can go through and kind of simulate a machine kind of bringing something up and maybe dumping it somewhere. But later on, they'll also be controlling the system through programs, through RoboPro. So they will program it to possibly run on a timer and have it go in one direction for a certain amount of time and then switch to another direction, in addition to possibly adding sensors so that it would know when one of the carts has gone to one point and gone back.
And what you saw from Eugene just a moment ago gives you the opportunity to take a look at We have actually taken the kits that were provided by Fisher Tech, and we have sorted out the most common pieces and put them into these boxes that we purchased. Makes it easier for us to transport things around, to be able to move them. The kids can keep things organized, keep them together, etc. So it's just a little tool for us to be able to manage our resources.
So this is the structural stress analyzer that students use to test their trusses. So they create a truss design and then they put it inside the machine. They wrap a chain around one of the joints of their truss, and what this machine is doing now is essentially pulling this down, and it will display the amount of force that is being used on the chain. But then as you see the chain kind of tighten up on the truss, the force will begin to rise. And it will just continue going until the truss breaks or it reaches kind of like the bottoming out point. They kind of recognize this as reaching a maximum point. So right now you see it's kind of going up to 20, 29, 30. At some point in time it will reach the highest level, and as it breaks it will kind of drop off suddenly. And that's kind of how they indicate the maximum force that the truss will take.
You can hear it breaking now.
So you heard it break, and it got to about 47 pounds, and now it's kind of dropping down 30s, probably go down to the 20s soon. So at this point in time, they can stop the machine and record the value that the truss broke at and do their calculations based on that.
Right. It also gives a displacement as well. So how much it displaced it before it started to break is a good thing to know as well. So next year we'll begin our second class in Project Lead the Way, which will be the Intro to Engineering Design. That will be more of a CAD-based class where the students will have a lot of computer time doing designs on a CAD system. The year after that, we will be going into digital electronics, and that will be the third offering that we make under the Project Lead the Way banner. And we're looking forward to having a lot of interesting days coming ahead.
So who would be best for these engineering classes? Pretty much anyone who's interested in a class that they don't have to come every day and take notes and then do homework. It's a class where it's mainly projects, it's all hands-on work. So most of the time that they spend in class is working on projects across a few days in small groups. So you need to be able to work and talk and communicate with people well. In addition to being creative and wanting to solve problems that are related to real-world applications.